For a century, wind power has meant one thing: giant spinning blades against the sky. But a new generation of turbines is emerging, and they don't spin at all. One design uses a swaying mast that vibrates with the wind, generating electricity. Another sits silently on rooftops, capturing airflow with zero visible motion at all. No blades, no gearboxes, no bird strikes, just resonance and electricity. Today, we're uncovering how motionless wind power works and if it can scale. Hit subscribe because the wind no longer needs to spin to matter. In 1940, a brand new bridge in Washington state began to twist violently in the wind. The Tacoma Narrows Bridge collapsed within months, a textbook case of aeroelastic flutter. For decades, engineers treated this resonance as a danger to eliminate, never as energy to capture. Then, in 2012, a small Spanish startup asked a different question entirely about that same force. Vortex Bladeless wondered, what if a structure was designed to vibrate on purpose? Instead of fighting vortex shedding, they built a mast that leans into the wind's rhythm. By 2015, their first working prototype proved the concept, a mast that swayed and generated power. Meanwhile, on the other side of the wind energy world, a different idea was taking shape too. At the University of Houston, researchers studied how wind actually flows over building rooftops. They noticed something. Wind speeds up dramatically right at the edge of every flat roof. That accelerated airflow became the foundation for an entirely new kind of wind harvester. This company, Aeromine Technologies, built a static wing-shaped unit with no spinning parts. Two very different paths, one swaying mast, one motionless wing, both rejecting the spinning blade. This isn't just academic curiosity. Cities are desperate for power sources that don't need open land. Traditional wind farms need wide open space, far from people, something dense cities simply don't have. These bladeless designs were built specifically to fit where conventional turbines never could, right in our cities. Both ideas sound almost too simple, but the physics behind them is genuinely fascinating, and that's next. So how does a swaying mast actually turn wind into usable electricity? It comes down to magnets. Inside the base, an alternator system uses magnetic induction to convert oscillation directly into electrical current. A clever tuning system uses magnetic repulsion to adjust how the mast responds to wind speed. As wind speed increases, the mast's effective stiffness changes, keeping the oscillation efficient and controlled. There's no gearbox, no spinning rotor, and remarkably few moving parts compared to a conventional turbine. Now let's look at the rooftop unit. Aeromine's design works completely differently, through pressure, not vibration. Wind hitting the building creates fast-moving air right at the rooftop edge, exactly where the unit sits. Inside, two vertical airfoils create a low-pressure zone, like the wings on a race car, inverted. That low pressure pulls air through internal piping, spinning a small turbine connected to a generator. From the outside, absolutely nothing moves. The only motion is hidden completely inside the unit. Conventional turbines have hundreds of moving parts that wear down: gears, bearings, blade pitch motors. Both bladeless designs strip nearly all of that away. Fewer parts to break means fewer reasons to climb up there. Each Aeromine unit produces around 5 kilowatts, comparable to a strong residential solar array per device. Buildings typically install 20 to 40 units along the rooftop edge, facing the prevailing wind. Two completely different mechanisms, magnetic induction versus pressure-driven airflow, both producing power without a single blade. By 2015, Vortex Bladeless had a working prototype, but turning it into a real product needed funding. So the small Spanish team launched a public crowdfunding campaign on Indiegogo to raise awareness and cash. Their goal was $50,000. People around the world started backing them almost immediately. Within a month, they'd raised over $77,000, 154% of their goal. On average, more than 45 new backers joined every single day of the campaign. At the same time, the founders were quietly pursuing something much bigger, $5 million in venture capital. They were seeking that investment at a company valuation of $13 million, a bold ask for such a small team. But the crowdfunding campaign wasn't really about the money. It was about proving demand existed. One stretch goal stood out: funding a pilot installation thousands of miles away, in India. The idea was simple: bring a radically different energy source to a place that needed it most. Crowdfunding campaigns like this rarely make headlines for the money raised. $50,000 is modest by tech standards. What made this campaign notable was the geography. Backers spanned dozens of countries across multiple continents. For a tiny startup with only a handful of employees, that kind of global attention was extraordinary validation. But validation and funding are only the beginning. The real test is whether the technology performs in the field. So let's look at the actual numbers. How much power do these devices really produce? Thousands of ordinary backers, most pledging small amounts, helped push an unconventional idea toward reality. This is often how breakthrough technology actually grows, not with massive funding, but with belief. From that early momentum, both Vortex Bladeless and Aeromine kept pushing their designs toward real deployment. Let's start with raw output. A recent study measured a Vortex-style mast producing about 36 watts. That sounds tiny, but remember, this is a small-scale device designed for sensors and off-grid power. In testing funded by the European Union, a 6-meter prototype captured up to 40% of available wind energy. By comparison, the larger Vortex Mini design runs about 30% less efficient than a conventional turbine. But here's the trade-off. You can fit roughly double the number of these masts into the same space. Less efficient per unit, but potentially similar output per square meter once density is factored in. Manufacturing costs tell a similar story. These masts cost roughly half of a conventional turbine to build. And because there's no gearbox or lubrication needed, the operating lifespan is estimated between 30 and 90 years. Noise output stays below 20 Hertz, effectively silent to the human ear, even up close. Now let's revisit the rooftop units. Aeromine units each generate about 5 kilowatts under good wind conditions. These aren't just lab numbers either. Vortex has tested prototypes in real outdoor conditions across Spain. Aeromine, meanwhile, has installations being evaluated by major companies, including a chemical manufacturing facility in Michigan. It's worth being honest, both technologies are still early stage and skeptics question whether they'll scale economically. That skepticism is healthy. Every energy technology, including solar panels decades ago, faced the exact same doubts. With 20 to 40 units along a rooftop edge, that's potentially over 100 kilowatts per building. That's a meaningful supplement to a building's energy use, though not enough to go fully off-grid. Vortex Bladeless has been honest about this too. They're not trying to replace conventional wind farms. The goal is urban, distributed, and off-grid power, filling gaps where giant turbines simply can't go. So the real numbers paint a clear picture: modest but meaningful power in places that need it most. Let's zoom out. Why does any of this actually matter beyond a few rooftops and research labs? The global energy grid is under enormous pressure from data centers, electric vehicles, and growing populations. Distributed generation, small power sources spread across many buildings, is becoming essential, not optional, for resilience. Bladeless wind devices fit naturally into that picture: quiet, compact, and able to sit almost anywhere. Now let's talk ethics, starting with birds, because that claim deserves a closer, honest look. Conventional turbines kill birds primarily through direct collisions with spinning blades, which are often nearly invisible in flight. Bladeless devices simply remove that collision risk entirely. There's nothing spinning for a bird to hit. But that's not the whole story. Large wind farms also displace birds simply by existing in their flight paths. Smaller, distributed devices may reduce that habitat disruption too, though long-term wildlife studies are still limited. Let's talk materials. These masts are built from carbon fiber composite, strong, light, but not easily recycled. As these technologies scale, end-of-life material recovery will need real attention, a challenge shared across renewable energy. There's also a question of access. Who actually benefits first from this kind of technology? Remember that India pilot ambition from the crowdfunding campaign? That kind of intent matters for equitable deployment. If these devices stay confined to wealthy buildings and tech demos, their broader impact will remain limited. So what comes next? Vortex Bladeless is working toward a much larger industrial prototype this year. The goal is proving this technology can operate at a scale that's actually relevant to the broader power grid. That means finding scaling partners, companies with the manufacturing power to build larger electromagnetic generators. Aeromine is following a similar path: more pilot installations, more data, more validation from real buildings. Think back to early solar panels, expensive, inefficient, and dismissed by many as a niche curiosity. Decades of incremental improvement turned that niche curiosity into one of the cheapest energy sources on Earth. Bladeless wind technology is at that early stage right now, promising, imperfect, and still finding its place. The honest version of this story is more interesting anyway, not a miracle, but a genuine possibility. Neither technology is going to replace the wind farm, and honestly, neither one is trying to. Instead, they're carving out a new category entirely: wind power for places wind power never reached. Rooftops, courtyards, parking structures, remote sensors, spaces too small or too awkward for traditional turbines to use. It's a quieter kind of energy revolution, not a single dramatic leap, but thousands of small ones. So the next time you walk past a quiet rooftop or a swaying pole, take a closer look. It might not be decoration. It might be one of thousands of small machines quietly generating power. Wind power spent a century defined by size, speed, and spinning blades cutting across open landscapes. Now it's quietly becoming defined by something else entirely: stillness, precision, and clever physics. The wind doesn't need to spin to change everything. Sometimes it just needs to sway. The wind just learned to hold still. Hit like, share this with someone, and subscribe to SynthCosmos. We cover the science reshaping our world as we know it every single week. We'll see you in the next one.